I'm opening it up for questions about problems at 5 on the homework. First one we're going to go over. Which one?
14, 15, 16.
14, 15, 16. All right, so we've got 14, 15, we've got unit conversions. Let's just do one of those. Let's do 15. So in 15, we're going from which unit to which? Was it?
I thought.
No, yeah. Okay, so let's do 14 because 14 was actually on the homework. All right. Okay, I only give you guys a subset of that. Guys who are at home, sorry if you did the whole thing, but I can post it next time. Okay, so 14, we're going from 28 centimeters to inches. Anytime we do one of these unit conversions, it's always good to write out what it is that we're doing. So, centimeters to inches, can we do that in one step? Do we know a conversion between centimeters and inches?
Yes.
Yes, all right, great. So, what's the first thing we're going to do here? Yes?
You put 2.5 centimeters over 1 inch.
No. Before we do that, before we do anything with centimeters, we need to start by setting this up correctly.
28 over 1.
Right, we're going to rewrite this starting quantity, this starting distance is 28 over 1, 28 centimeters over 1. Then what are we going to do to it? Anybody? Change from centimeters to inches. So I've got centimeters here. I'm going to have to do what with those centimeters? Do I want centimeters in my answer?
No.
No, so I got to do what? I've got to not only get inches in there, but I've also, what do I need to do with the centimeters? I got to get rid of centimeters. How do I get rid of something on the top of a fraction? What's an easy way to do that? Multiply it by the same thing on the bottom of a new fraction. Remember, when we multiply fractions, we can always cancel things out that appear on the top of one fraction and the bottom of a fraction. So in order to cancel out these centimeters, we can put centimeters on the bottom here. Now what are we trying to change to?
Inches.
Inches. So we're going to write inches up here. We're always writing whatever unit we're going to in the numerator of the fraction we're multiplying by, whatever we're getting rid of in the denominator. Now, how do we make this balance? How many inches go to how many? Yes. Okay, now we can multiply. Our centimeters will cancel out. We've got 28 on the top. We've got 2.54 on the bottom. What unit do we have? So unit? Inches. Notice the centimeters, they disappeared. They both got canceled out. 28 over 2.54 inches. You don't have to go and do the arithmetic at that point. Yes?
Right, on that problem, what's it called? I didn't know I could just put it like over like that. So like I think I was trying to like divide it.
Yes?
But I couldn't do that.
Yeah. Yeah, so, I mean, you could. I think it's 11 and change.
Yeah.
But, yeah, with these unit conversions, don't bother multiplying out or dividing out. I'm not going to require you guys to do that. All right, next problem somebody wants to go over.
20. Wait, what did you say the answer was for 27?
For which one?
27.
27. Give me a second. Pull it up. 27 is 34.86. It's often a good idea to draw yourself a picture. So notice for 16, someone read 16 aloud for me.
The length of the rectangle is 22 inches. The width of the rectangle is 13 inches.
All right. It's always helpful, I think, in these kind of problems to draw yourself a picture. What kind of a thing are we dealing with?
Something.
What kind of thing? A rectangle. Okay. So we've got a rectangle here. This is number 16. 16, we're dealing with a rectangle. What information do they tell us about the rectangle?
The length and the width.
Okay, what's the length? Is what?
22 inches.
22 inches. And what's the width? 13 inches. Okay. Notice how all that I've done so far is taken the information from the problem and just get it into my workspace. It's a good habit to get into. Okay, now what are they asking for? The perimeter. We want to know what the perimeter is. Okay.
So outside of the
You size it
Oh,
up.
there's the.
Right, we add all the sides together. The perimeter is the distance to go around. The distance around is the perimeter. So, to add up the perimeter here, what are we going to have? So,
44.
where did you get those numbers from?
It's like 22 plus 22. It's the top and the bottom.
Right,
This is-
and we need all four sides added up together for our perimeter. So we've got 22 plus 13, or as you said, 44 plus 26, which is going to give us what? 70 what? Dollars? Inches. 70 inches. Draw yourself a picture for these ones. Make your life easier. Any other questions from problem set 5 that you want to go over?
Maybe
Maybe? Going once?
30.
No, 30. All right. This will be the last one. So, here we've got a line. Or, actually, we don't have a line. What do we have here in 30? What kind of thing do we have here in number 30? Look at your books. Come on, we're on page 29.
Wait, you
We're on page 29.
Did you assign us
It's
to
not a
do
line.
30?
All right.
I'm sorry?
Did you assign us to do 30?
I think so. I meant to, at any rate.
It's an array.
It's on my list.
Think.
I can do it.
It's not a ray and not a line.
Because it has dots on the end.
Right, and not arrows. If it ends at both ends, it's not a line, it's a line segment. A line will go on forever. All right, we've got these dots. What's the mathematical term for these dots?
Points.
Points. We've got 3 points on the lines, and we're calling them X, Y, and Z. All right. Again, always start with just getting your information on the page. So what information do they give us?
X, Z is 18 and 2 over 5.
Gallons?
Let's see. X, Y is 1 over 5, 15.
Not 1/15, a little bit more than that.
6 and 1 over 15.
Dollars?
Miles.
Miles. All right. So here's the information that they gave us. They tell us the length of xz. They tell us the length of xy. What are they asking us to find?
Y, Z.
YZ. Okay. Now, look at the image here. How can we find the length of YZ given the lengths of XZ and XY? What are we going to have to do?
Add.
Well, let's take it. Let's be careful. XZ. Excuse me. XZ is this whole measurement here. Where's YZ that we're trying to get? Yeah, it's only from Y to Z. So one.
18 and 2 over 5 minus 6 and 1.
Right, we're going to take XZ and we're going to subtract XY. Notice YZ is the length of this whole thing XZ minus this length here. Right? Everyone see why I set it up that way?
Yes.
Okay. Now we can just plug in our numbers that they gave us. So YZ is equal to, instead of XZ, what's the length of XZ?
The length.
Yeah, what's XZ? 6 and 1/15. All right, so we've got two mixed numbers that we're subtracting. How are we going to do that?
Just gonna do it.
Okay, well,
Common denominator.
we need a common denominator. So instead of
6 over 15.
6 over 15, right? Minus 6 and 1/15. All right. Then when we subtract, what are we going to get?
12.
Yes. 18 minus 6 is 12. Scoops of ice cream.
Miles.
Miles. 12 and 1/3 miles. There you go.
What's
So-
wrong?
Two things that you have to do here. One is figure out which things am I adding or subtracting together and in which way. Then you've got two mixed numbers to subtract. Okay, moving on to lesson 6, page 29, lesson 6. Hopefully somebody's watching, but oh, looks like somebody's watching. Hello. You can say hi in the chat if you want. It's okay, I don't feel lonely or anything.
Who's online?
What was that?
Who's online?
I don't know. They're 2 or 3 students. It could be. All right. So, okay. So let's talk a little bit about addition. We talked last week about adding signed numbers. So somebody give me a quick recap of how that works. When we're adding numbers that have signs, so we're talking about positive and negative numbers, how's that going to work?
Yes.
How's that going to work? Well, what happens if we add two positive numbers?
You get a
positive number.
Yeah, we're just going to add together the numbers and we'll get a positive answer. What about if we're adding two negative numbers?
Negative number. A bigger negative.
We'll get a bigger negative. So negative 2 plus negative 5 is going to give us
-7.
negative 7, right? We just take 2 and 5 and add them together and then keep it negative. What happens when we have one that's negative and one that's positive?
Then, depending on the bigger number, it might be positive or negative.
Right, our answer could be positive or negative depending on which one of those two numbers is further from 0. What's another way of saying further from 0? Whichever one has a greater what?
Oh, this
The distance from 0. What's another way we can talk about the distance from 0?
big number. Or really, really small number.
So we can say that 2 and negative 2 or 3 and negative 3 have the same what? The same distance from 0, or there's another term for it. It's
Ambulative.
Give some good guesses here.
Abstract.
Abbreviated
Absolute value.
Absolute value. Remember, absolute value refers to the distance from 0 of a number, whether it's positive or negative. So anytime you take the absolute value of a number, you're always going to get a
That's it?
what? A positive or negative?
Oh, positive.
Right, always positive. If it's negative, you make it positive. So negative 3, what's the absolute value of negative 3?
At least 3.
The absolute value of negative 3 is what?
3,
Is 3. What's the absolute value of 3, or positive 3?
3.
3. They're both the same. So when we've got a negative and a positive, we're actually going to subtract the two of them. And then the answer, its sign will depend on which has a greater absolute value. So the difference between negative 7 plus 3 and 7, we're going to subtract the absolute values of these numbers. We'll do 7 minus 3, either way, right? Is this one going to be positive or negative, though?
Negative.
How can we tell it's going to be negative 4? Is our answer going to be positive or negative?
Positive.
Positive, because 7 is further, positive 7 is further away from 0 than negative 3 is. So whichever one is further from 0 wins out. Okay. But are on different sides of the 0, we talk about them as opposites. So what's the opposite of 7?
-7.
Negative 7. What's the opposite of 10?
-10.
What's the opposite of negative 8?
-8.
Yes.
8.
Yeah, 8, sorry, yeah. What's going to happen when we add a number to its opposite?
Oh, it's going to equal 0.
It's always going to equal 0. Zero. Why? So when we add them together, neither wins. We get stuck right back in the middle. Right? If you go 7 feet forwards and 7 feet backwards, you end up right where you start. Okay, we can also call this the additive inverse. The opposite of a number is called its additive inverse. Why? Because the inverse of adding that number is adding its opposite. In terms of addition, how do we undo adding 3? How do we undo adding 3? If I add 3 to something and then I realize I didn't want to do that, I want to undo it, what do I have to do now? Subtract 3. Or, this is an important concept for the whole year. And you'll see as the year goes on why. Adding Or let me put it this a little differently. Instead of subtracting, we can add. What do I mean by this? Well, if we've got 10 minus 3, what does that equal? What's 10 minus 3? 10 minus 3. Easy, yeah, 7. Instead of subtracting 3, we can also add negative 3. What's 10 plus negative 3?
-7.
It's also 7, not negative 7.
I thought you said -10. It's okay. We're good.
Okay, all right, good. So these are equivalent to each other. 10 minus 3 and 10 plus negative 3, that's the same thing. Why that becomes useful, we'll see a little bit later. All right, and if you want to undo addition, better than using subtraction, for the purposes of this class, this is actually going to be more handy. Adding negatives is going to be more useful than subtracting positives. Anyone want to tell me why? Anybody know why? What's a big difference between subtraction and addition? Subtraction has a restriction on it that addition doesn't. What's the difference? What's 10 plus negative 3? 7. What's negative 3 plus 10? 7. What's 10 minus 3?
7.
What's 3 minus 10?
-7.
Negative 7. With subtraction, the order matters. But with addition, order doesn't matter. That's why this is going to be more useful. Now, because the order doesn't matter, anytime that we have multiple signed numbers that we're adding together, so if you look at the top of page 31, that's where we are now. So for example, if we want to add -5, 4, -3, and 2, the order doesn't matter. So what's going to be the easiest way to do this? Well, we could go left to right, but we could also do what?
Add the 2 negatives.
Right, we could combine the negatives and combine the positives first. So if we combine these two negatives, -5 and -3, what are we going to get? -8 plus what? What's 4 and 2? +6. And what are we going to get at the end? -2. All right, there's our answer. By adding the negatives first, adding two things that have the same sign is easier because we're just adding. Adding is easier than subtracting, right? Yes? Yeah, I would rather add than subtract. You could do it in any order you want. You could combine 4 and the -3 first. It doesn't matter. But often it's going to be easiest to combine all your negatives together, combine all your positives together, and then at the end, do that rule where you subtract the absolute values and give it the sign of whichever one is the greater absolute value. Okay. So, let's see. What else? The other two sections in this lesson cover the same idea. I'll give it to you as the rules they present in the book on page 32. They call it algebraic subtraction. Because when we're doing algebra, this is generally what we're going to want to do instead of subtraction. Algebraic subtraction, you should be familiar with how to do this. Algebraic subtraction means that A minus B, if we have one number A minus another number B, that's the same as saying A plus -B. That is always the truth. Always the truth. That is always true. That always holds. That's the definition of how addition and subtraction work and how negative and positive numbers work. But we can exploit this in very useful ways. I'm not picking up what you're putting down. Okay, which is exactly what I said here. So let's just take a look at page 31. One of the examples on there. So this is example 6.5, down the bottom of 31. We've got -4 minus 3 plus 2 minus 4 minus 3 minus 2.
So I don't mind.
Yeah, I don't like this. I don't like subtraction. For this class, you should learn not to like subtraction.
I
Why?
don't like it.
Yeah, I don't like it either.
Yeah, leave it alone.
I don't like subtraction because subtraction I have to do in a particular order, and it's also just harder than addition.
Subtraction is trash.
And I want to make
it.
I want to make my life easier. So, what am I going to do to get rid of all the subtraction here? How am I going to rewrite this?
You could
I
add
don't
up
know.
all of the subtraction thing.
Say that again?
You could add up all of the negative.
Right, we can think of this as adding negatives instead. So we can think of this, we've got negative 4, and then what are we adding to it?
Negative.
Adding negative 3, plus what? 2, plus what?
Well, the plus two can just cancel out.
Well, we'll get there. Plus what?
Negative.
Plus negative 4, plus negative 3, plus,
You can't see the board.
I'm sorry,
Negative.
plus negative 2. Yes, yes.
Negative.
All right. You can add in parentheses like this. In fact, when you're dealing with negative signs, it's often a good idea to use parentheses to help you keep things straight. Okay, there's a difference between the negative sign and the subtraction sign. Yes?
Yes.
Yes, there's a big difference. In fact, what I like to do, you don't have to do this, but what I like to do is when 3, as opposed to 2 minus negative 3, notice how my subtraction is in the middle in terms of top to bottom, and the minus sign I put up top. That's something I recommend doing, but you can also use parentheses like this to help you keep things straight. All right, so when we're doing this, once we convert it so that there isn't any subtraction anymore, what are we going to do here? How are we going to simplify this further? Add all the negatives together. So negative 4 plus negative 3 is what? Okay, so we got negative 16. And how many positive numbers do we have? Oh, just the one. Plus what? 2 equals?
Negative.
Yes, negative 14. Now, as one guy had pointed out, before we do this, because adding a number and its opposite always gives you what? 0. Adding the 2 and adding the negative 2, of bothering to put those in there. Then all we need to do is add negative 4, negative 3, negative 4, and negative 3. And we'll get negative 14 still. Look for things like that. Make your life easier. Cancel things out when you can. All right. Questions about any of this material? So it's from problem set 6. Numbers. Here, I'll give you the set. Is 6, 10, 12, 13, up, 22, 25, 27, 28, 29. Okay, so 6, 10, and then 22, 25, 27, 28, 29. Let me get you guys the sheets. Start working on that. 6 plates. 25. Here you go. Here you go. Here you go. Here you go. You know what? Thank you. All right. Goodbye.
Goodbye. Wait,
No, I'm just saying goodbye to these guys.
Goodbye to you too.
All right. Sorry.